Hi, this is Mrs. Wiederholt, and welcome to my video on composition and inverse of radicals. Now let's get started. Do you remember the notation for composition of functions f of g of x? The main thing you need to remember is to work from the inside out. And what that means is you will either start with g of x or you will figure out what g of x is first. And then when you have that answer, then you plug that into the f of x equation. So let's look at a linear example. It's one that I'm sure you've done before. We are given f of x equals 3x plus 1 and g of x equals x minus 9. And then what we are supposed to find is f of g of x. We will do that by taking what g of x is equal to, which is x minus 9, and we will substitute x minus 9 for the x in the f of x equation. So that's going to look like this. I will start out with that f of x equation, 3 times x. But instead of x, I'm putting in x minus 9. And then I continue with the f of x equation, plus 1. So do you see how we have inserted the g of x equation into the f of x equation? So now let's continue to simplify. 3 times x is 3x. 3 times negative 9 is negative 27. And then I have plus 1. And so I have 3x and negative 27 plus 1 is negative 26. And that is our answer. We have f of g of x is equal to 3x minus 26. Okay, now let's move on. Now we will look at some radical or square root examples. Okay, in this red example, we are given f of x equals the square root of x plus 5 and g of x equals 2x minus 1. And we are to find f of g of x. Now we will do this by taking what g of x is equal to and substituting it for the x in the f equation. Now it will look something like this. We start out with the square root, and instead of just x plus 5, we are substituting the 2x minus 1 plus 5, and then plus 5. Okay? Now we can start to simplify. Under the square root symbol, I still have 2x, but I also have negative 1 plus 5, which would be plus 4. And so this is the answer to f of g of x. Now, what if we were asked to find g of f of x? That means this time we start with the f of x equation, or what it's equal to, what f of x is equal to, and we substitute that for the x in the g of x equation. Okay, so let's do that. So I start out writing the g equation, 2, and instead of times x, it is times the square root of x plus 5. And then I continue with the g equation, and it's minus 1. Now, it just so happens that this is already as simplified as you can get it, so that would be your answer to g of f of x. Now let's move on to the green example. We have f of x equals the square root of x minus 3, g of x equals 4x squared, and we're asked to find f of g of x. So let's get started. So I will take what g of x is equal to, and I will substitute it for the x in the f equation. So that's going to look like this. Instead of x minus 3, it's 4x squared minus 3. And it just so happens that this is the final answer. It cannot be simplified any more than that. So f of g of x is equal to the square root of 4x squared minus 3. Now let's look and see what we would do if we had to find g of f of x. This time, we're taking the f of x equation and substituting it for the x in the g of x equation. So it will look like this. We'll start out with 4, and instead of 4 times x, it's going to be 4 times the square root of x minus 3. Now in the g of x equation, after the x is squared. So that means after the square root of x minus 3, we have to square that also. Now in this one, there is more that we can do. Now remember, anytime you have a radical that's squared, the answer is just the radicand without the square root. For example, the square root of 5 squared is simply 5. So when we look at our example that we're doing here, we have the square root of x minus 3 squared. So that simply is x minus 3. So that's going to look like this, 4 times x minus 3. Now we can distribute the 4, and we have 4x minus 12. And that's going to be our answer. G of f of x is equal to 4x minus 12. Now let's talk about inverse functions. Now we first talked about inverse functions when we were dealing with quadratic functions and quadratic equations. So let's kind of review that just a little bit. So what does inverse mean? It simply means opposite. For any given equation, we can find its opposite or its inverse. So if we have two equations that are opposite, that means they will be a reflection of each other. And which line will they be reflected over? The parent linear function, y equals x. There are only two steps for algebraically finding the inverse. Number 1, switch x and y. And that's literally what it means. You will switch the x with the y. And number 2, solve for y. Now let's look at a couple of examples. First, we have y equals 3x minus 7. So step number 1 is to switch the x and the y. So I'm going to do that. And I will have x equals 3y minus 7. Now I'm ready to do step number 2, which is to solve for y, which is really just a two-step equation. I will first add 7 to both sides of the equation, and on the left side I will have x plus 7 equals 3y. Now I'm ready to divide each term by 3, and when I do that I have 1/3 x plus 7/3 equals y. So I have y equals 1/3 x plus 7/3, and that's the inverse of y equals 3x minus 7. And if we were to graph these, you would see that they would be reflections of each other over the parent linear function, y equals x. Now let's do our second example. Y equals 1/2 x plus 3. So again, step number 1 is I switch the x and the y. So I'm going to have x equals 1/2 y plus 3. Now I'm ready for step number 2, which is to solve for y. So I'm going to start out by subtracting 3 from each side of the equation. And on the left side of the equation, I have x minus 3. And on the right side of the equation, I have 1/2 y. Now, there are two ways that you can move the 1/2 from the right side to the left side. I like to multiply by the reciprocal. And what that means is 1/2, what's the reciprocal of 1/2? It's 2 over 1. So I'm going to multiply each term by 2. And I have to multiply every term by 2 so that it doesn't change the value of my equation. Now when I do that, I now have 2x minus 6 equals y. Because 1/2 times 2 is 1. They cancel each other out. So here is my inverse. Y equals 2x minus 6. Now I hope this video has helped you understand and maybe remember a composition of functions and inverse of functions, and I look forward to working with you again. Bye-bye.